Today's explainer is your absolute ultimate masterclass on diagnosing fuel pressure regulators. Listen, the goal here is to get you fixing cars like a veteran foreman, instead of just randomly firing the parts cannon and hoping something sticks. A fuel pressure regulator might seem like a really simple piece of hardware, but honestly, it's the absolute gatekeeper between the fuel pump and the injectors. If it fails, that entire air-fuel mixture calculation gets totally compromised. So let's get into the exact procedures that'll keep our diagnostic times low and our repair quality high.
All right, here's our game plan for today's explainer. 1. Understanding fuel system types. 2. Spotting a bad regulator. 3. The 6-step diagnostic workflow. 4. Avoiding common diagnostic traps. 5. Handling GDI and boost. And finally, number 6, safe repair and maintenance.
Okay, let's kick things off with Section 1, Understanding Fuel System Types.
Before you even pick up a wrench, you have to know exactly what kind of system you're dealing with. In an older, return-style system, that regulator sits right there on the fuel rail near the injectors. It uses a calibrated spring and engine vacuum to hold the diaphragm in place, and it literally just bleeds the excess fuel right back to the tank. But on most vehicles built after the year 2000, you're going to see a returnless system. With these, the regulator is built directly into the fuel pump module inside the tank itself, and the ECU pulls all the strings electronically by varying the pump's duty cycle.
Moving right along to Section 2, Spotting a Bad Regulator.
There is a really stark contrast you need to recognize when a customer comes in complaining about drivability. If the internal spring in that regulator loses tension over time from fatigue, you're going to get chronically low fuel pressure. The engine is literally starving. That means hard starts, rough idles, and lean misfires under load. But what if that rubber diaphragm completely ruptures? Well, the whole system overpressurizes. It forces raw, unmetered fuel straight through the vacuum line into the intake manifold, drowning your cylinders in a rich flood. You'll get black smoke, and trust me, you will smell that raw fuel.
So listen up, rookie. You might be wondering, what actually kills these things? Well, contamination and aggressive ethanol blends will absolutely shred the rubber diaphragms in older systems. These regulators are precision devices. Running low-quality fuel or pushing E15 plus ethanol through an older system that wasn't designed for it degrades that rubber incredibly fast. You combine that chemical attack with the intense, constant heat cycling under the hood, and that diaphragm just becomes brittle, cracks, and eventually tears wide open.
And here is why you cannot ignore this. A rich running engine from a faulty regulator won't just cause a little misfire. It will literally melt down a $1,000 catalytic converter. All that excess, unburned fuel gets pushed right into the exhaust, superheating and just completely destroying the converter substrate. At the exact same time, raw fuel is washing past the piston rings. That causes severe engine oil dilution, which can wipe out your engine bearings in no time, all while rapidly fouling out the spark plugs with thick black carbon. It's a total domino effect.
All right, time to get our hands dirty. Section 3, the 6-step diagnostic workflow. I need you to follow these 6 steps religiously. We always sequence from non-invasive visual checks to the hardcore data analysis. Start by visually hunting for leaks or fuel odors. Then, hook up your mechanical gauge for a static key-on, engine-off test, followed right up by a dynamic test with the engine actually idling. Step 4 is critical. Shut the engine off and watch the gauge for a pressure leak down. And while you're doing all this, grab your scan tool. If the car has a fuel rail pressure sensor, you must cross-check that the live OBD2 scan data perfectly matches your physical gauge readings. Don't skip that.
I always tell my guys, a 30-second vacuum line test can save you a 3-hour misdiagnosis. It's so simple. With the engine running, just pop that vacuum hose off the regulator safely. Put your finger over the port. If it's wet with raw fuel or you smell a super heavy gas odor, that internal seal is toast. Boom. Raw fuel spits out, the diaphragm is completely blown, and your diagnosis is 100% confirmed safely, right then and there.
Let's talk about the mistakes I see green techs make every week. Section 4, Avoiding Common Diagnostic Traps.
Seriously, why do so many rookies replace a perfectly good fuel pump? I'll tell you why. Because they see a rapid pressure bleed down during their hold test, and they instantly blame the pump. They completely miss the fact that a bad regulator is leaking the pressure right back into the tank. When you watch your gauge drop from 40 psi to 0 in just a few minutes, you have to isolate it. Safely clamp the soft fuel supply line. If the pressure suddenly holds with that line clamped, the pump check valve is fine. The culprit is your regulator bleeding it down the return line. Let's talk data. When your scan tool shows a long-term fuel trim hitting negative 25%, the ECU is screaming. It's desperately trying to pull fuel away because you have a massive rich condition, which is incredibly likely to be from an overpressurized rail.
Remember, positive fuel trims mean the computer is adding fuel to fix a lean issue, like maybe a weak regulator spring. But heavy negative trims, the engine is choking on fuel. You gotta learn to interpret this. Fuel trims give you a direct, real-time window into fuel delivery health. And here are 2 classic traps that'll catch you off guard. Number 1, a leaky Schrader valve core on your test port will mimic a failing pump. If your gauge isn't sealing tightly against the valve, it bleeds pressure and looks exactly like a fuel system failure. Verify your equipment first. Number 2, a blown regulator often vomits raw fuel directly into the intake, right onto the map sensor, completely ruining it. If you find a ruptured diaphragm, you gotta track where that fuel went. If it contaminated the map sensor, the car is still gonna run terrible even after you put the new regulator in.
All right, we are stepping up to the big leagues now. Section 5. Handling GDI and boost.
You need to demand absolute precision here. An old throttle body injection system might happily chug along on 9 to 13 psi. Standard multiport injection, that hovers around 35 to 65. But gasoline direct injection, GDI uses a high-pressure mechanical pump driven right off the camshaft to boost that pressure up into the thousands. We're talking 500 up to 3,600 psi. You absolutely must consult your specific OEM service manual to know exactly what baseline spec you are measuring against.
Now, what if you're working on a modified, turbocharged engine? You got to remember that boost actively fights the fuel pressure trying to enter the cylinder. The manifold pressure is literally pushing back. So the regulator has to rise at a 1-to-1 ratio with the boost to compensate. If you are servicing a modified car with an aftermarket adjustable regulator, verify it's subjected to periodic calibration checks. If it's out of calibration under heavy boost, that engine will run dangerously lean and you'll melt a piston.
This is a massive safety warning. You must, and I mean must, safely depressurize both the low and high pressure lines before cracking open a GDI system. 3,000 psi is literally enough pressure to inject fuel directly through your skin. Do not mess around with this. Follow the service manual, command the pressure down electronically with your scan tool, and let it fully bleed down. And pro tip, since the high-pressure pump houses the regulator and rides on the cam, always inspect that cam follower for wear while you're in there, and only use top-tier OEM equivalent precision parts.
Let's bring this explainer home. Section 6. Safe repair and maintenance.
Here are my strict foreman's rules for wrenching out in the bay. We build a culture of quality here. That means you always thoroughly clean the dirt away before opening any fuel line. Hit it with brake cleaner. If a piece of dirt falls into an open fuel rail, you're going to clog a brand new injector immediately. Always will leave the line pressure by pulling the fuel pump fuse and cranking the engine first. And when you're installing the new part, properly lubricate those new O-rings with clean engine oil so they seat beautifully and don't tear, preventing incredibly dangerous fuel spray or vacuum leaks.
Look, a regulator generally has a service life of about 80,000 to 150,000 miles. But honestly, that lifespan is completely dependent on strict fuel filter maintenance. You can prevent premature degradation entirely just by swapping the filter on time. Dirt and varnish in the fuel system literally act like sandpaper rubbing against the precision internal needle valves and seats. You've got to advise your customers to stick to their maintenance schedules to keep that abrasive contamination out of these expensive components.
So I'll leave you with this question. If a cheap, failing regulator has the power to completely destroy a $1,000 catalytic converter, are you thoroughly checking it during every single major misfire diagnosis? Think about that before you wrap up your next job. Don't skip the basics, all right? Cross-check your scan tool data, run your pressure tests properly, do your visual inspections, and prioritize strict safety protocols. You've got the knowledge to nail these workflows every single time now. Get back out to the shop floor, apprentice, and let's put these skills to work.